Drainage water recycling is a practice where one would collect surface runoff and subsurface drainage discharge into a pond. That pond will then store the water temporarily as a reservoir. So we're located in southwestern Minnesota. It is a prairie pothole, previously glaciated region. So our conditions over the course of a year, 6 months we can have frozen conditions and snow, and 6 months we can have growing conditions. So it makes our site pretty unique from the standpoint of looking at how can we actually implement, and can we actually implement, drainage water recycling in a site this far north. When we start looking at that type of a system, the reason that we actually implemented it here in this part of the world is really thinking about future climate change. When we start thinking about future climate change and the projections are that the distribution of rainfall and precipitation is going to change in the next 50 to 100 years. What's going to happen is projections tell us that we're going to be wetter in the spring and drier during the summer. So when we start thinking about why we're trying to do this, not only is it from an agronomic, a sort of a productivity yield reasoning, but also from a water quality standpoint. So when we think about the water quality aspect of this, any of the water that we're capturing in the spring or during the course of the summer from our surface runoff or our subsurface drainage in our reservoir that contains dissolved nutrients, it's not leaving our site and not flowing down through our river systems and ultimately to the Gulf of Mexico. So we're also trying to retain some of those nutrients here on the landscape in order to be able to reutilize those nutrients later on during the growing season.
So anytime that we can find a way to reduce our costs and increase our output, we're looking at those opportunities. Drainage by itself is the highest return on investment we can make. So if we can supplement the drainage with controlled drainage and water recycling, putting that water back on the landscape, it's a win-win for us.
The water actually comes from about a 320-acre area, which supplies the water for the pond through the subsurface drainage systems and the surface runoff. Primarily that's occurring during the March, April, May period of time, so primarily a spring type of a system for us. We can also actually start to recharge some of our pond, our reservoir during the fall, during fall recharge periods when we might get surface runoff or subsurface drainage starting in September after the growing season. Now, when that reservoir becomes full, there are two outlets to that reservoir. One is just a normal outlet that flows when the water level reaches a certain elevation in the pond, just to maintain water level at that elevation. Occasionally, we do have large events here in southern Minnesota, and those large events can produce large volumes of water. In those particular cases, we actually have an overflow system on the reservoir. That overflow system allows excess water in that pond to actually outflow from the system and then drain into the ditch systems and the rivers nearby, just to try to maintain, again, that elevation of water in that pond. In our particular case, we can actually pump the water from the reservoir back onto our fields where we're using on-surface drip irrigation. You could also use subsurface drip irrigation, overhead irrigation, or subsurface drainage irrigation through the drain pipes. So drought and heat stress can have a very negative impact on crop production in southern Minnesota, particularly if it happens at the wrong point in time in the growth cycle of the crop. One of the things that we actually are doing is we're measuring the crop stress by looking at the crop canopy temperature. So the crop will actually transpire water just like perspiration for human beings, and it helps to cool the plant. So we actually have some sensors that are out in the field that are measuring the temperature of the canopy. We also use soil moisture sensing. So we actually will go into our plots and we'll actually take soil moisture measurements on a weekly or bi-weekly basis, depending on the time of year. And we use that soil moisture content to be able to use kind of what we call a checkbook method for determining how much plant available water is in the soil for the plant. When we reach a certain threshold, that's another way that we use to help indicate when we need to actually add supplemental irrigation water from our drainage water recycling sites. Once we've determined that need, we actually will go out into our system, and we actually have a series of on-surface drip irrigation lines and manifolds that we actually will go in areas of the plots at different points in time through our irrigation system, and also depending on the threshold of where the crop is, how much need there is, we can actually adjust the timing of how long the irrigation happens, whether it happens early in the day, late in the day. And using an on-surface drip irrigation system like we're using is extremely efficient, and it also ends up putting water right in the zone near the surface where the highest density of roots are, so the plants can really take that water up quickly. We have several different systems out in our field site. We have a rain fed, which doesn't require any supplemental irrigation. We have two others that are really relevant. One is a limited irrigation, and the other one is a full irrigation. So the limited irrigation, we allow the soil, as our checkbook method, we allow the soil to get to about a 50% depletion of plant available water. What that means is that the soil has used up about 50% of the water, and that's sort of our threshold, our trigger, in order to look at what's the soil moisture to start turning on the irrigation system. For a full irrigation system, basically we're trying to maintain soil moisture at what we call field capacity. So we're trying to maintain soil moisture at a fairly high level, particularly in these fine texture soils. That translates into a lot of available water for that crop to use during the growing season. And one of the things that we have seen is that even though the crop may look like it's healthy and growing fine, that once we might get really, really dry conditions or dry, windy conditions, that the crop can start undergoing drought and heat stress really, really quickly. That may be sort of hidden stress. So being able to monitor that and then respond by being able to add supplemental water from our drainage water recycling site can help alleviate that and help farmers then maintain high levels of yield and productivity from their crops. So in terms of thinking about the expected potential benefit and yield to the farmer, in the 4 years that we've worked with this practice, we've had some relatively wet years. However, in half of those years, we actually have been able to put supplemental irrigation down, and we've actually seen about a 10 to 15% yield increase in our corn production, slightly less in our soybean production. It was about 10% yield increase. And in those cases, we've actually used relatively small amounts of water, anywhere from 2 to 4 inches of water. It was all that we actually ended up having to use when we were irrigating those crops.
The biggest concern we have with our drainage systems right now is the nutrient loading that goes on. And so if we can prove through our research that by reintroducing those nutrients back into the crop, we're not sending them downstream, which is a win-win for everybody.
In the future, I see a pretty high ceiling for the practice of drainage water recycling. I really believe that it's going to have multiple benefits. It's going to have some water quality benefits by retaining water. So you might reduce some of the peak flows that you might see downstream. It's going to retain dissolved nutrients in that water that otherwise might flow down the rivers and streams. And then it also has the opportunity to be able to provide a yield advantage to the farmer by being able to add water to a crop that may need additional water resources.